In this presentation, I'll walk you through a RAG system, Retrieval-Augmented Generation, developed specifically for museum documentation. You'll see how we can build an intelligent system that helps users explore museum collections through natural language questions powered by AI. The system enables users to ask questions about artwork collections in plain language and receive accurate contextual answers based on real documentation. This is especially useful for museums with large collections, where finding specific information can be difficult. We've built a complete pipeline that processes user questions, retrieves relevant documents, and generates intelligent answers. The system is composed of three main components: data preparation and vectorization, large language model integration, and an API interface. First, we process the data by loading museum documentation from JSON files, splitting it into chunks of 500 to 1,000 tokens with some overlap, and generating vector embeddings using sentence transformers. These vectors are stored in a FAISS database, enabling fast and accurate document retrieval. Second, we integrate a large language model, in this case, Gemini 1.5 Flash, which generates responses based on the retrieved documents. This combination ensures both relevance and fluency in the answers. Third, we provide a REST API built with Fast API, offering a clean, developer-friendly interface with full Swagger documentation and input validation. We use the Minneapolis Institute of Art's collection dataset, which includes rich metadata such as titles, descriptions, artist information, and cultural context. Our data ingestion script loads the JSON files, processes the strategy ensures that context is preserved while keeping the segments manageable for embedding. We use a sentence transformers model well suited to art-related content to generate embeddings. These embeddings capture the semantic meaning of the text, allowing the system to find relevant content even if the wording doesn't exactly match the user's query. We store everything in a FAISS index, enabling fast similarity search, which is critical for real-time question answering. Let's see the system in action with some example queries. Show me American paintings from the 19th century. The system retrieves the most relevant documents and generates a comprehensive answer with specific examples from the collection, including source citations. Find artworks with floral motifs or nature themes. The system correctly interprets the semantic meaning of the query and finds relevant artworks, paintings, ceramics, and textiles, even if they don't explicitly mention flowers. What can you tell me about Japanese ceramics in the collection? The response includes detailed information about types of ceramics, historical periods, and examples from the collection, showing how the system blends LLM knowledge with curated data. Find portraits by female artists. The system understands the combined criteria and accurately returns portraits created by women. Show me artworks related to religious themes. The system finds diverse religious artworks across different cultures and periods, showing a strong understanding of broad thematic concepts. The fast API-based REST API accepts questions and returns structured answers along with their sources. It includes comprehensive input validation and robust error handling. The system is fully documented with Swagger, making it easy for developers to explore the API, see available endpoints, and test example queries. We've also created a simple web interface. Users can type their questions and receive answers instantly. Each answer is accompanied by source documents, providing transparency about where the information came from. We track performance metrics. Most queries are answered in under 2 seconds, and all interactions are logged for quality monitoring and future improvements. We've implemented caching to accelerate responses to frequently asked questions. This is especially helpful for popular queries. We log every question, retrieved document, and generated answer to better understand user behavior and continuously improve the system. Error handling is carefully designed. When no documents are found or a model issue occurs, the system responds gracefully with helpful feedback instead of technical errors. The architecture is scalable. We can easily add new content, update the embedding model, or switch to another language model provider as needed. We've developed a complete RAG system tailored to museum documentation that meets all project requirements. It delivers accurate, contextual answers using real source material. We've implemented efficient data processing, advanced language generation, a professional API with full documentation, and robust error monitoring. This system shows how Retrieval-Augmented Generation can make museum collections more accessible and engaging for visitors, staff, and researchers alike. The system is ready for deployment and can be extended to other museum collections or specialized use cases. Let me know if you'd like a timing guide or visuals to go with it.